Bismillahirrahmanirrahim.
Assalamualaikum warahmatullahi wabarakatuh.
I am Nur Izzati Rashidah binti Razali. My matrix number is 182569.
And I am Nur Fadila binti Mak Fauzi and my matric number is 182162.
Today we are going to solve question 12. The question is, in a physics lab, a cube slides down a frictionless incline as shown in the figure below and elastically strikes another cube at the bottom that is only 1/2 its mass. If the incline is 30 cm high and the table is 90 cm off the floor, where does each cube land? The hint is given, where is both leave the incline moving horizontally. So, to find where does each cube land, the first step to be taken is we have to apply the law of conservation of energy, where the equation given is W and C equal to delta KE plus delta PE. So we know that previously on the previous paper it was said that the incline is frictionless, so W and C is equal to 0. Okay, so delta KE is equal to KE final minus KE initial plus PE final minus PE initial. So actually we know that the initial velocity for block A is 0 because we have 0 velocity, there is no movement, so we can cancel this kinetic energy initial, and at the end of the movement there is no potential energy for block A because we are already on the ground floor, or we already stopped, so we don't have any potential energy for final. So the equation left are 1/2 mv final squared minus mgh equal to 0. So we can change this into we can change the place here. Mgh equal to 1/2 mv squared. So we can see that there is no given mass on the question. There is no m, so we can cancel m, and we are left with gh equal to 1/2 v squared. So g is 9.81 multiply with 0.3 meter, which is 30 cm given on the question, equal to 1/2 v squared. So we can find the velocity for block A, which is equal to set of 9.81 times 0.3 over 1/2. So it is equal to 2.43 meter per second. So we know that the cube is going to collide at the end of the incline. So to get the speed of each cube after collision, we use the law of conservation of momentum, where momentum initial momentum equal to final momentum, and 1 is equal to A, 2 is equal to B, because I use 1 here to initiate that it is cube A, and 2 to initiate that it is cube B. So initial momentum equal to initial final momentum, m1 v1 initial plus m2 v2 initial equal to m1 v1 final plus m2 v2 final. So we know that to initiate block B, and block B at first place there is no movement, no velocity, so velocity is 0. 0 times m is equal to 0. So we are left with m1 v1 initial equal to this. So we can substitute this 2.43, which is velocity of block A, into this initial velocity of block 1, which is block A. So m times 2.43 equals to mv final of A plus 1/2 mv final of B. So we just change the place of this value, where 2.43 is equal to before that I realized that we can actually cancel this m because we don't have any m on the question given. So m is all over the place here, so we just cancel the m's, and we have 2.43 equal to v final of A plus 1/2 v final of B. So this is our first equation in order to get the speed of each cube after collision. Okay, so we have to find the second equation to find the either VA or VB. So the second equation is, we have to find the second equation under elastic collision law, where we have to use this equation, which is VA initial minus VB initial equal to negative of V final of A minus V final of B. Okay, so to ease our calculation, we just group the A, cube A at one side of the equation and B at one side of the equation. So we have V initial of A plus V final of A equal to V initial of B and V final of B. So we actually have this V initial of A from the previous calculation, this. So we substitute 2.43 into this V initial of A. So we have plus V final of A equal to V final of B, and we just change minus both sides with 2.43, and this is gone, and there is minus 2.43 here. So this is the second equation. So we already have two equations, the first one and the second one. So we are ready to find the velocity of either V final A and V final B. So we substitute 2 into 1 equation to the first equation. So the first equation just now is 2.43 equal to V final A plus 1/2 V final B. So we just substitute 2.43 here, V final B here, and minus with this V final VA, we change it into V final B minus 2.43 here, and we plus with 1/2 V final B, and then we have 4.86 equal to 3/2 V final B, and then we have the V final B is equal to 3.24 meter per second. And this is only the third equation. We already have the third equation. So we substitute the third equation into the second equation. So the second equation is what we have just now. So VA equal to V final B. We have already V final B, so we substitute 3.24 here, and we minus with 2.43 from the second equation. So substitute this both value, and we have the velocity of final of cube A, which is 0.81 meter per second.
Okay, now we are not over yet. We are one step away from getting the final answer for this question. Okay, in order to get the final answer, which is where does each cube land, which is indicates the distance, we use this equation, delta x equal to V naught xt. Okay, the delta x is the distance where we want to find this, and we already have the V naught x, but we don't have the t. So now we must find the t, which is time taken to land on the ground. To find the time taken, we use this equation, delta y equals to V naught yt plus half ayt squared. So delta y is y final minus y initial equals V naught yt plus half ayt squared. Okay, the y initial is equals to 0, and V naught yt is equal to 0 too. So now we just have y final equals to half ayt squared. So we move t to this on the other side. So we get t equal to sec 2yf over ay, and it will be like this, t equal to sec 2h over g. So now we substitute the h, which is it will be like this, sec 2 times 90 times 10 to the power of negative 2 over 9.81, which is this is the gravity. So now we can get the time, 0.429 seconds. So this is the time. Okay, after we have the time, we can find the distance. So distance, where does each cube land? For cube A, we use this equation, delta x equal to V naught xt. So delta x equal to V naught xt. We just substitute the V naught x, which is V naught x is 0.81 while t is 0.429. So we get the distance for cube A. So cube A is land on 0.35 meter on the ground, while for cube B, Delta x equal to V naught xt. Delta x equal to V naught xt. So we substitute the V naught x, which is 3.24, while t we substitute, which is 0.429. So we get the answer for cube B. Cube B land on the ground at 1.38 meter.
So, hooray! We already got the answer.
Thank you.
May the forces be with you. Wassalamualaikum warahmatullahi wabarakatuh. Bye, madam.
Bye.